Like Thursday, Friday.
Okay, recording started. So today we're looking into the combinations. Combinations we using when the order in which we select object is not important. When order is not important. Permutations when order is important. Combinations when order is not important. So we denote combinations C and R or and R. Those are equivalent notations. Now, as we said that, yes.
In the methods exam, you're allowed to write NCR.
Yeah,
Okay.
absolutely. This is absolutely valid notation. No
She said that it's
difference.
better to use N on R, but like.
No, this is correct. It's a proper notation.
Okay.
Same as this. You can use any of it. It doesn't matter. Now, if we, for example, we choose when the order is important, so permutations. If we find, let's say, permutations of 3 out of 5, let's recall formula for permutations. It will be 5 factorial divided by 5 minus 3 factorials, which will be equals. This is 2 factorials.
Don't you also have 3 factorial on the bottom?
That's
No.
combinations.
For permutations, no.
Ah.
How we get this? This we choosing through object out of 5. How many choices we have for the first place? 5, for second 4, for third 3. So that's what we will get here. That will be equal 60. But that's when order is important in which we choosing them. If order is not important, then it doesn't matter we choose through object, but we can arrange them in different order. So there will be less combinations. So to get number of combinations, we need divide number of permutations by R factorial. Because this is in how many ways we can rearrange our objects. R factorial ways. And if we calculate, this is when order is important. But combinations, order is not important. So for example, if we choosing object 1, then object 2, object 3, order important, it's not the same as 2, 1, 3. With the combinations, when it doesn't matter what we have chosen, doesn't matter in which order, that will be counted as 1. So combination, we have R factorial less, so we will get formula for combination, which you should know from method, that is n factorials divided by R factorials n minus R factorials. That is the combinations. Example, where we apply combinations. For example, let's consider first, no restrictions. We have committee of 5 students chosen from 7 boys and 4 girls.
Which question is this?
It is example 1 from the booklet in the 9E, 9F. So, 7 boys, 4 girls, and we need to choose 5. If there is no restrictions, in how many ways we can choose committee?
12 choose 5.
Yes, 12 choose 5, but combinations or permutations. Combinations. So we will have C 12 choose 5, which will be 12 factorials divided by 5 factorials, 7 factorials, which will be equal 400
Isn't it? Oh, that one.
sorry, it's 11. You say 12 and I repeated 12.
Oh, it was.
It's 11. 7 plus 4 is 11.
And what's it?
11. So we'll be 11 factorials, and so we have 5, but this will be 11 minus 5 will be 6 factorials, and that will be equal 462. Now, let's consider if there are some restrictions. For example, committee has to have exactly 2 boys and 3 girls. So how are we choosing? We now choosing 2 boys out of 7. And we choosing, how many is it? 3 girls out of 4. So we times by 3. That is the number of the possible committee which has 2 boys and 3 girls. Makes sense why we're doing this? Because we can choose, it says that it has to be 2 boys which can be chosen out of 7, and there has to be 3 girls which are chosen out of 4. Yes?
Can you explain why it's multiply, not addition?
Because for each combination of 2 boys, we can
It's
have
3 different.
those combinations of girls
Yeah, yeah.
for each of them.
Okay, yeah.
So that's why I'm multiplying. And that will be equal 80, that will be equal 84. Now, if how many committees can have at least 3 girls? How we do if each committee must have at least 3 girls? So how many girls it can have? 3. It cannot have 5 because we have only 4 girls.
So it's 84.
So we have need to this plus, now will be plus when we choose all 4 girls, as we have 4 girls. How many such committees we will have? If there are only 4 girls and we can be only 1. So we will have 84 plus 1 will be 85 committees which will have at least 3 girls. Sorry, not right. 4 girls, but the committee of 5. The committee of 5, and we have 7 boys.
Isn't it 1 plus?
So we have this plus we choosing C for
What's 7?
with 4 times, but we choosing 1 boy out of 7, which is equals 7. So that will be equal 91. Committee of 5, not of 4. So we choose, this is how many ways we can choose 3 girls, 2 boys, and that's how many ways we can choose 4 girls, 1 boy, which this will be equal 7. And one more, determine probability determine the probability that determine the probability that oldest and the youngest students are on the committee. Probability that oldest and youngest student to be on the committee. Any ideas how we can solve the question? Ask. Find the probability that the oldest and youngest student will be on the committee. Yes.
Could you do 9 choose 3 on 11 choose 5? Because you already know that 2 are already on the committee.
Yes, we know the 2 already on the committee. So now we how many committee members we need to choose? How many left? 3. And how many people left? 9. So that will be C93. Because we already choose 2 members, 1 oldest, 1 youngest. And out of 11 people, we have 9 left. And we choose only 3 out of them because there are 5 members of the committee, 2 already chosen. And that in how many ways we can choose committees. How many committees we can choose with which have oldest and youngest. And to find probability, what is probability? Number of favorable outcomes divided by the total number of outcomes. Total number of outcomes is C11(5). And if you calculate that, that will be 2
Why 11? Why do you divide by 11, choose 5?
This is the total number of possible committees. We choose committee with no restrictions. What is probability? Number of favorable outcomes. This is number of favorable outcomes.
Oh, it's probability. Oh, okay.
Yeah, find the probability, and that will be equal, if you do calculations, 2 over 11. That's how we calculate combinations and combinations with restrictions. That's all like new for today. Like, subscribe and donate to help fight terrorist countries and organizations, crush Iran, Hamas, Hezbollah, etc. Support Ukraine and Israel.